For Algebra 2 at Trig, we're working on Unit G2, which is sine, cosine, and tangent ratios. A trigonometric ratio, a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. These ratios are constant among all right triangles. We know that a 30, 60, 90 triangle has a short leg that is half of the hypotenuse. It doesn't matter if it's a small 30, 60, 90 triangle that's drawn on your fingernail or a big 30, 60, 90 triangle that's drawn in a parking lot. The short leg is always half the hypotenuse, or the hypotenuse is double the short leg. Well, there are relations to every type of triangle or a right triangle. We don't memorize them all except the special ones, which we call the 30, 60, 90 and the 45, 45, 90. They have the most reasonable calculations for us to somewhat memorize. The rest of them will all be done with a calculator. We use words like opposite, adjacent, and hypotenuse to describe the sides of a right triangle. The trigonometric ratios are always given in relationship or relation to an acute angle. It has to be an acute angle, not a right angle. When we talk about the opposite, we're talking about opposite the acute angle, adjacent to the acute angle. And the hypotenuse is always the longest side. It's always the side that's not one of the legs. We're going to be studying sine, cosine, and tangent. There are three other ratios, secant, cosecant, and cotangent, but those are all closely related to these, and we don't need those particular trig ratios to solve triangular problems that we're working on. So you won't see that with these lessons. You might see that in the future. All right, when we talk about sine, sine is spelled S-I-N-E, but it's abbreviated S-I-N. On your calculator, it's abbreviated S-I-N. We don't pronounce that sin. We don't say cos, we say cosine, we say tangent. So the sine of an angle, will always be the opposite side over the hypotenuse. Opposite over hypotenuse. That is for the sine. The cosine is always the adjacent side over the hypotenuse. And the tangent is always the opposite side over the adjacent side. So notice how all or each of those ratios are different. None of them are repeats of each other. The biggest challenge is going to be remembering what is the ratio for sine, what is the ratio for cosine or tangent. We have a little trick for you to help remember that. Right now, we need to talk about what does opposite mean. Seems pretty simple what opposite might mean, but let's be sure that we don't make mistakes with that. So we have to be going from an acute angle. So here, they're talking about the leg that is opposite angle A. They're going from the acute angle A. So the opposite side is going to be the one across from the angle A. That's the opposite side. In terms of the angle A, that's the opposite side. The adjacent side is the leg that is right next to it. Some people ask about, well, the hypotenuse is right next to it. That's adjacent. Well, yes, it is, but that's across from the 90, and that will always be called the hypotenuse. That's not going to be adjacent because that's hypotenuse. So the adjacent is not the opposite side, and it's not the hypotenuse. It's the one next to the angle that you're talking about. That's the adjacent. A way for us to remember what the ratios are. What is the ratio for sine or cosine or tangent? There's a common one called SOHCAHTOA. SOHCAHTOA, the S in SOHCAHTOA stands for sine. The C in SOHCAHTOA stands for cosine, and the T stands for tangent. So there's your sine, your cosine, and your tangent. And then the O and the H. The O happens in two of them to be the opposite. So it's opposite over hypotenuse is your sine. And if we look up in our notes at what sine was, it was the O and the H. It was the opposite and the hypotenuse. So there's your O and the H for SOHCAHTOA. So that helps you remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So these next few examples, we're not doing much with it, but it might be the way that a question could be phrased on the SAT. The SAT might say, find the tangent of D. What is the relation or the ratio for the tangent of D? So you first need to find where angle D is located. There it is, angle D. So we're going to go across from angle D to identify the opposite side. Opposite angle D would be that side. Adjacent to angle D would be this side, would be the one next to it, would be the 45. And of course, the 75 will always be the hypotenuse, because it's always across from the 90. For this triangle, the hypotenuse is 75. So we're going to look at the tangent of D. So we know using SOHCAHTOA that tangent is opposite over adjacent. So the opposite side is the 60, and the adjacent side is the 45. So it is 60 over 45. Well, we can reduce those. If you want to divide each one of those by 15, we could get 4/3. If you wanted to talk about the decimal for those, 60 divided by 45 or 4 divided by 3, they're both going to give you the exact same decimal. If we round this to 4 places, we could call that 1.3333. When we figure out the decimal, we're not doing tangent of that. We're just doing the fraction itself, or the decimal. Now notice that the tangent of F has a different opposite. From its point of view, the opposite side, we use a different color. From the F, over here is the opposite angle F. Over here, this is the adjacent angle F. It's adjacent to the angle F. The hypotenuse does not change. So when we talk about what is the tangent from F, the opposite is the 45 and the adjacent is the 60. We, of course, can still reduce that by 15 for both of them. We get 4/3. And most of us are familiar that that's the decimal of 0.75. You could put down 2 zeros if you had to, or your 4 decimal spots, but 0.75 will be sufficient because that's the exact answer. So now you go ahead and you try the tangent of J and K. You can pause the video and come back and check your answers to see how you did. So when we're looking at this from the J, the opposite side is 24. So tangent of J, opposite is 24. The adjacent side is 32. 8 goes into both of those, so 3/4. That happens to be 0.75. That's a coincidence that matches the other problem. Tangent is not always 0.75. Tangent of K is the opposite would be the 32 and the adjacent would be the 24. 8 goes into that 4 times, 3 times, we get 1.3333. So on your SAT, they might ask you, what is the tangent of K? So you would have to look at the picture they provide you. They might have different numbers. And the opposite over adjacent would be your 32 over 24. Then you'd have to check to see the options. Have they reduced it or are they using unreduced numbers? It all depends on how they display their answers. So the sine of A. Well, from the A's point of view, the opposite is across from the A. The opposite side does not touch the A at all. The adjacent side does touch the A, and the opposite to 90 is the hypotenuse. And with that in the adjacent, they both touch the A. So if we're going to talk about the sine of A, remember we're using the idea that sine, cosine, and tangent. Sine is opposite over hypotenuse, O and H. So the 40 and the 85. I know at least 5 goes into both of those numbers. So 5 goes into here 8 times. 5 goes into here 17 times. So we get 8 over 17. And we can get a decimal out of that by saying 8 divided by 17. We would get 0.470, and we would round up the 5 to a 6 because the 8 is 5 or bigger. The cosine of A is the adjacent over hypotenuse, is the 75 over 85. Again, I know at least 5 goes into both of those numbers. 5 goes into 75. 15 times, and 17 times. So 15 divided by 17 is 0.8824 because the fifth number is 5 or bigger. So that makes the fourth number get rounded up. You can go ahead and try number 2. So the sine of P, from P's point of view, the opposite side is across from it is the 10. The adjacent side is 5 root 5. And the hypotenuse is across from the 90. Label your triangle. I can't stress anything more important than labeling your triangle so you know specifically what the sides are. So the sine of P, using SOHCAHTOA, we know that sine is opposite over hypotenuse. So the opposite is the 10, the hypotenuse is the 15. So again, 5 happens to go into those. So we get 2/3. That's 0.6667 because the next number would be 5 or bigger. So we round it up. The cosine of P is going to be opposite, actually adjacent over hypotenuse. That's the cosine is AH. So that's 5 root 5 over 15. We can reduce the 5 and the 15 to become root 5 over 3. 5 goes into 15 3 times. The 15 is on the bottom, so the 3 goes on the bottom. So our root 5 divided by 3 is going to be 0.7454. Notice that the sine and cosine are always less than 1. Every time, always, because the hypotenuse is always a bigger number. So the opposite over the hypotenuse, the smaller number over a larger number, will always be a fraction less than 1. A decimal less than 1. In tangent might switch. Tangent might be a number less than 1, or it might be a number greater than 1. Because you're doing opposite over adjacent, it all depends on which number is bigger when you do the opposite over adjacent. Now we can actually use trigonometry to do something. In the past, we have used Pythagorean theorem to solve for the missing side. If you know two sides of a right triangle, you can use hypotenuse squared equals leg squared plus leg squared to solve for the missing side. But what if we only have one side length and they give us an angle? If you only have one side length, you need something else. You need to know something. So if they give you a side length and an angle, then we can solve for missing sides. There's a little chart that we're welcome to use. The K stands for what do you know? You got to know two things. You need to find at least something, and you're going to be using one of the trig ratios. When we do these calculations, specifically on your graphing calculator, you need to be sure you are in degree mode. So you got to hit the mode button to verify that you're in degree mode. Some other scientific calculators will default to degree mode, but the graphing calculator seems to default to radian mode. And we'll talk more about radians in the future. So a good way to test what you're working with is if the sine of 30, you already know what the sine of 30 is. 30 degree, 30, 60, 90 triangle. The opposite would be the short leg over the hypotenuse. You know that that's going to be half the hypotenuse. The opposite is less than the hypotenuse, so it's going to be 0.5. So it's a great way for you to always test to see what mode your calculator's in. Sine of 30 is 0.5. So you need to be sure you are in degree mode. All right, we'll come down and we'll solve. On the SAT, you will not have to give a decimal. I would not expect you to give a decimal, at least on the non-calculator. Sounds silly now for me to say it like that. There would be a calculator portion and a non-calculator portion. The non-calculator portion, you might do trigonometry, but you would only be given the ratios or given the equation that you would use to solve for it. So what do we know? We know we have a 17-degree angle. We also know that across from that 17 is the 9, and that would be called the opposite. That's the opposite side. What do we need to figure out? We need to figure out x, which is the adjacent side. So we're going to be working with the opposite side and the adjacent side. So if we're going to use opposite and adjacent, we think about this as, again, SOHCAHTOA. So if we're using the O and the A, that's not sine because it has the hypotenuse in it. Cosine has a hypotenuse in it. Tangent has the opposite and adjacent. Opposite and adjacent. So we'll be using tangent. That is how you determine which trig function you use. So the tangent of your 17, from the 17's point of view, the opposite over the adjacent would be your equation that you've set up to solve for x. Now to solve this, you could write a 1 underneath your trig function, so now you have a proportion. And that helps you know exactly which pieces are cross multiplying. So you have x times the tangent of 17, and that's going to equal 9 times 1, which is just 9. Now we want to solve for x. X is sometimes on the bottom of the fraction, sometimes x is on the top of the fraction. It all depends if it's the opposite or the adjacent that you're looking for. Problems can change, problems can be different. So we cross multiplied, the x came over to the tangent of 17. Now we have to get the tangent of 17 away from there. So we are going to divide by the tangent of 17. That gives us an approximated answer because we're going to get a decimal. They're asking us to round to the nearest tenth. So they said 9 divided by tangent of 17. That is 29.4. Rounded to the nearest tenth. 29.4. Our next example, here it's a little trickier. Here they give us both letters. We have to figure out both legs. It's not a 45, 45, 90 triangle, so the legs are not exactly the same. It's close, but not quite exactly the same. The hypotenuse is 14. So across from the 90 is the hypotenuse. That doesn't change. Across from the 44 would be considered our opposite side. Next to the 44 is considered our adjacent side. So you want to label your triangle. Now, if we're going to solve for x, using our little chart here, this might help you stay organized. You don't have to use it, but it does help with some organization. If you're solving for x, that's what you need to know. That's the need to know value. X is your opposite side. What do we know? We know that the hypotenuse is 14. So 14 is the hypotenuse. And the other thing we know for sure is that we have a 44-degree angle. You need to be sure that that angle that you're using there is less than 90. Is an acute angle. So it's not in the same order that we'll write it, but it does have an opposite involved and a hypotenuse involved. So using SOHCAHTOA, when we're dealing with opposite and hypotenuse, tangent has adjacent. We don't have adjacent. Cosine has adjacent. Oh, we don't have adjacent. We have opposite and hypotenuse. We're going to work with sine. That's the trig function we're going to use. So we say sine of 44 equals the opposite over the hypotenuse. Look where I put the x this time. In the previous problem, the x was put on the bottom of the fraction because it was the adjacent side didn't have the value. In this case, it's the opposite side. And because the hypotenuse did, we put the 14 on bottom in the hypotenuse spot. You can still put it over 1 if you want. That helps you stay organized. And you cross multiply. That's 14 times the sine of 44. That's going to equal 1 times x. Just write x. There's no dividing needed for this one. That's why it's so important to be sure that you write out your work. No magical answers. Show your steps. 14 times the sine of 44. You don't have to hit times. You don't have to use parentheses around the sine. You may get all the same answer. 9.7 would be rounded to the nearest 10th. Then for our next, they wanted us to solve for y. Y was our unknown. So what do you need to know? You need to know y, which is considered the adjacent side. We still know about the 44-degree angle. We still know about the 14, which is your hypotenuse. So that tells us that we're working with the adjacent and the hypotenuse. So thinking about SOHCAHTOA, the adjacent and the hypotenuse, the A and the H, that's only cosine. Cosine is the only AH involved. So we're going to use cosine. So cosine of 44 equals the adjacent, which is our unknown, over the hypotenuse. set that over 1. (14) times the cosine of 44. You don't have to use a time sign. We get 10.1. Approximately your y value. Now you go ahead and try the next 3. You can pause the video and come back to it to verify your answers. So looking at the 36, the side opposite, the 36 is of course the opposite side and the hypotenuse. So what do we know? We know the 36-degree angle. We know the 11, which is the hypotenuse. We need to know the x, which is the opposite side. So that tells us that we're going to use sine. So sine of our angle equals the opposite over the hypotenuse. Put it over 1 and cross multiply. We're showing our steps. We need to use a calculator. 11 times the sine of 36 is 6.5 approximately, if we're rounding to the nearest tenth. Just got to follow the directions to what they ask you to round by. The next question, look for the angle that they give you, and then notice the information. So the side opposite is the 18. The x is the adjacent side. Doesn't look like we're using the hypotenuse at all. So what do we know? We know a 65-degree angle. We know 18, which is the opposite side. We need to know the x, which is the adjacent. And because we're working with opposite and adjacent, that is tangent. So tangent of 65 equals opposite over adjacent. Look where the x landed this time. It landed on the bottom of the fraction. If it lands on the bottom of the fraction, when you start to solve for it, it's going to come over to the trig ratio. So this is the situation where you have to divide. We don't have to divide if the x is on top of the fraction, because when the denominator comes over, we could just multiply those together. But in this case, we bring the x across, we have to move the tangent of 65 away. So the x value is approximately going to be 18 divided by the tangent of 65, 8.4 if we're rounding to the nearest tenth. And our last one, showing all our work. We know we have a 57-degree angle. We know that we have the adjacent side, looking for the hypotenuse. So the adjacent side is the 14. What we need to know is the hypotenuse. So we're going to use cosine. Adjacent over hypotenuse, 14 over x. Want to be certain that you put that in the right order, because you get a different answer. So this is x times the cosine of 57. That would equal 1 times 14. You can divide by your cosine of 57. So x is approximately 14 times the cosine of 57. 7.6. Oh, did I times it? Yeah, good job. We are dividing by the cosine of 57. That's better. Let's see if we can make sense out of which answer would be accurate. 25.7. All right, we know that the hypotenuse has to be bigger than the two other sides. All right, so that would be one quick way for you to know that something was wrong. If you get a hypotenuse that is smaller than a leg, something is wrong. Hypotenuse will never be smaller than a leg. Good job.